Imagine a tiny robotic explorer far from home, drifting through the endless blackness of space. Alone, yet carrying the hopes and dreams of thousands back on Earth, it journeys onward, a silent ambassador to the unknown. For 20 years, Cassini sailed the dark ocean of space, revealing Saturn's wonders. It sent back breathtaking images of swirling storms, icy rings, and mysterious moons, transforming our understanding of the distant giant and its family of satellites. But all journeys must end. On September 15, 2017, Cassini's mission reached its dramatic conclusion, a moment both triumphant and bittersweet for everyone who followed its voyage. The spacecraft turned toward Saturn and began its final descent, a deliberate, planned act. This was not a failure, but a carefully chosen finale, designed to protect the secrets of Saturn's moons from earthly contamination. Mission controllers watched with pride and sadness as Cassini plunged into Saturn's thick, swirling atmosphere. Years of dedication and teamwork had led to this moment, and emotions ran high as the final chapter unfolded. Fighting to keep its antenna pointed at Earth, Cassini sent back data, sampling the gas giant's atmosphere for the first time. Even as it descended, it continued to work, gathering precious information until the very end. Friction heated its shell, glowing like a meteor as it was torn apart by the world it had studied for so long. In those final moments, Cassini became a streak of light, a brief but brilliant flash in Saturn's sky. This final act protected Saturn's pristine moons and delivered one last stream of scientific discovery. Cassini's sacrifice ensured that future generations could continue to search for life on these untouched worlds. In its last moments, Cassini became a symbol of human curiosity and our drive to explore. Its journey inspired scientists, dreamers, and explorers everywhere to look up and wonder what lies beyond. Its signals traveled over 1 billion kilometers, carrying the final whispers of a dying explorer. Each bit of data was a farewell, a message from the edge of the solar system. Then, as predicted, the signals stopped. Silence. The mission was over, but its legacy was just beginning. Cassini was gone, consumed by Saturn, becoming part of the planet it had dedicated its life to understanding. Its journey was over, but its spirit endures in every discovery it made. But its story, and the discoveries it made, were just beginning to be told. Scientists continue to study its data, unlocking new mysteries about Saturn and its moons. The end of Cassini marked the start of a new era in our exploration of the cosmos. Its legacy will inspire future missions, reminding us that every ending is also a new beginning. Our story begins on a warm Florida morning in 1997, as the first rays of sunlight bathe the Kennedy Space Center in a golden glow. The air is thick with anticipation, and the world is watching. On the launch pad stands a towering rocket, its engines poised for ignition. Nestled atop is the Cassini spacecraft, accompanied by its brave companion, the Huygens probe, two marvels of engineering, ready to embark on a journey never attempted before. With a thunderous roar and a plume of smoke, Cassini blasts off, leaving Earth behind. Its mission? To unlock the mysteries of Saturn, the majestic ringed giant at the edge of our solar system. The path to Saturn is anything but direct. Cassini's journey is a cosmic dance, using gravity assists to gain the speed it needs. It slingshots past Venus not once, but twice, and then swings by Earth, harnessing the gravitational pull of each planet to propel itself farther into the solar system. Each planetary flyby is a feat of precision and timing, calculated down to the second. These maneuvers are essential, giving Cassini the momentum required to reach the distant world of Saturn, a place no spacecraft has ever orbited before. In the year 2000, Cassini soars past the giant planet Jupiter. Here, it captures breathtaking images of swirling storms and tests its scientific instruments, ensuring everything is ready for the challenges ahead. This encounter with Jupiter provides the final gravitational boost Cassini needs, flinging it on a trajectory towards Saturn. The spacecraft proves its resilience, showing it is ready for the long voyage through the cold, dark reaches of space. For nearly 7 years, Cassini travels through the vast emptiness between worlds, covering more than 3.5 billion kilometers. It endures cosmic radiation, frigid temperatures, and the loneliness of deep space. On July 1, 2004, after a journey of patience and perseverance, Cassini fires its main engine. With careful precision, it slips into orbit around Saturn, becoming the first spacecraft in history to do so. The maneuver is flawless. Cheers erupt in mission control as decades of planning and hope are realized. A new era of discovery has officially begun. Cassini is now our robotic emissary in the Saturnian system, circling the planet and its dazzling rings, ready to explore its many mysteries. Its arrival marks the beginning of an unprecedented era of exploration, as humanity's eyes and instruments reach farther than ever before. The stage is set for discoveries that will forever change our understanding of the outer solar system, revealing wonders we could only dream of. Saturn, with its shimmering rings and mysterious moons, is about to unveil secrets that have been hidden for billions of years. Cassini's journey has only just begun. The adventure is underway, and the promise of discovery lies ahead. Humanity, through Cassini, has finally arrived at the ringed giant, ready to explore, to learn, and to be amazed. Once in orbit, Cassini became a tireless photographer and scientist. For 13 years, it sent back images and data that rewrote our textbooks. Cassini revealed Saturn as a dynamic world, giant storms, changing seasons, and breathtaking rings. The rings, made of countless icy particles, were sculpted by tiny shepherd moons and shaped by gravity. Cassini discovered mysterious spokes and waves, uncovering the ring's constant motion. The spacecraft explored Saturn's diverse moons: Iapetus, half bright and half dark, Hyperion, a tumbling space sponge, and many more. Each moon was a unique world, mapped and studied in detail. Cassini painted a rich portrait of the Saturnian system, a place of beauty and surprising activity. It revealed interactions between rings, moons, and planet, showing how the system formed and evolved. Cassini wasn't just observing Saturn, it was getting to know it intimately. Among Saturn's dozens of moons, two stood out as extraordinary: Titan and Enceladus. These distant worlds, orbiting in the cold reaches of the outer solar system, would soon become the focus of intense scientific curiosity. Titan, larger than the planet Mercury, is the only moon in our solar system with a thick, hazy atmosphere. Its orange clouds hide a mysterious surface below, making it a world unlike any other. In 2005, the Huygens probe touched down on Titan, revealing a landscape shaped by methane rain, winding rivers, and vast lakes. Features eerily reminiscent of Earth, but made of alien materials. Cassini's powerful radar pierced Titan's clouds, mapping its seas and shorelines. What emerged was a frozen mirror of Earth's liquid cycle, with methane and ethane taking the place of water. Then came Enceladus, a small, bright, and icy moon, once thought to be just another frozen world. Cassini made a stunning discovery: plumes of water vapor and ice erupting from Enceladus's south pole, shooting hundreds of kilometers into space. Flying through these geysers, Cassini detected water, organic molecules, and salts, the essential ingredients for life as we know it, hidden within the icy spray. Beneath Enceladus's frozen shell lies a vast, warm ocean, kept liquid by the powerful forces of tidal heating from Saturn's gravity, a hidden sea in the darkness. This makes Enceladus one of the most promising places in the solar system to search for life beyond Earth, a true oasis in the cold. Thanks to Cassini, a once overlooked moon was transformed into a potential oasis, capturing the imagination of scientists and dreamers alike. Titan and Enceladus have forever changed our understanding of where life might exist, expanding the boundaries of possibility. The search for life now had new frontiers, no longer limited to Earth, but reaching out to the mysterious moons of Saturn. Cassini opened our eyes to these oases of possibility, inspiring us to keep searching for life in the most unexpected places. After 13 years, Cassini was running out of fuel for its thrusters. Without fuel, it would become a derelict, uncontrollable object in Saturn's system. The discoveries at Titan and Enceladus raised the stakes. These moons might harbor life. NASA faced a choice: abandon Cassini, risking contamination, or ensure it could never crash into these worlds. Planetary protection demanded responsibility. To preserve these pristine environments, Cassini's fate was sealed. The team decided to send the spacecraft into Saturn, where it would be destroyed. Saturn's atmosphere would incinerate Cassini and any Earth microbes it carried. This was not just an ending, but a final act of scientific preservation. The grand finale was born, a daring conclusion to a legendary mission. Cassini's end would protect the future of exploration. The grand finale was Cassini's boldest chapter. The spacecraft dove 22 times through the gap between Saturn and its innermost rings, a region never explored before. Mission planners had long avoided this area, fearing hidden dangers. Cassini used its main antenna as a shield, surviving each risky plunge. The gap was surprisingly empty, a major discovery in itself. These close passes let Cassini sample particles and gases, revealing a new perspective on Saturn. It mapped the planet's gravity, probed its interior, and observed the rings up close. The grand finale turned risk into revelation, making Cassini's end its most thrilling voyage. The mission's final act was its most daring. The grand finale dives revolutionized our understanding of Saturn's rings. Cassini measured the rings' mass, revealing they are much younger and lighter than once thought, perhaps only 10 to 100 million years old. The spacecraft discovered during rain, a constant shower of material falling from the rings into Saturn's atmosphere. This influx of ice and organics shapes the planet's chemistry and links the rings and Saturn in a dynamic relationship. The rings are not static, they are eroding, changing, and interacting with the planet. Cassini showed us that Saturn and its rings are locked in an ongoing cosmic dance. The system is alive, evolving before our eyes. September 15, 2017. Cassini's final day. In NASA's control room, scientists and engineers gathered to witness the end. Cassini fought to keep its antenna locked on Earth, transmitting data as it plunged into Saturn's atmosphere. For a few precious minutes, it became the first Saturn atmospheric probe, sampling the planet directly. On the screens, the final telemetry streamed in. The thrusters reached their limit. The signal faded. "Loss of signal," announced a voice. Quiet applause, tears, and pride filled the room. Cassini's end was peaceful, a perfect conclusion to a historic mission. It remained a scientist to its last breath, sending back knowledge from a place we can never visit. The mission's legacy was secure. Cassini's mission is over, but its legacy endures. The data it returned will fuel discoveries for decades. Cassini reshaped our view of Saturn, not just as a planet, but as a complex, dynamic system. Its findings redirected the search for life to icy moons like Enceladus and Titan. Future missions, like Dragonfly, are inspired by Cassini's discoveries. The mission was a triumph of international cooperation, uniting scientists from around the world. Cassini stands as a symbol of human curiosity and our drive to explore. It reminds us that the quest for knowledge transcends borders. Cassini's story is our story, a testament to our courage and imagination. The images and data it sent back inspire new generations